This video will be about point-slope form, writing linear equations from data, and parallel and perpendicular lines. So point-slope form is the equation y minus y1 equals m times x minus x1. Sometimes instead of giving you the slope and the y-intercept, which would be this y equals mx plus b form, they give you the slope and a point, which we would then have to plug in. Usually though, after we plug it in, we eventually want to make it look like that y equals mx plus b. So let's say we have a slope of 1/2 and a point of 4, -2. So now we have to go plug these in to find the actual equation of the line. They want a line that has a slope of 1/2 and goes through this point. So we've got to go plug these in, but we have to know the right places to plug stuff in. We have y minus from the formula, and then we need to replace y1 with whatever value down here is a y value. Well, our slope we know will replace m, and we know every point goes x, y. So this -2 is what we're going to plug in for y1. Equals, then we find our slope. We're going to replace the letter m with 1/2 times x minus x1. Well, that's the x value of our point, so x minus 4. Now usually we do want to simplify this so that we get y completely alone. So if we have a minus minus, that changes to a plus, and this 1/2 is going to have to be distributed. 1/2 times x is 1/2 x. 1/2 times -4 is -2. You can plug that straight into the calculator by doing 1 divided by 2 times -4, and it'll come out with your -2. So now we still want to get y completely alone, which means we have to minus 2 from both sides. We're going to line it up with its like term. So we get y equals 1/2 x minus 4. So that would be the equation of our line, and we want it written this way because that's the form we use to graph a line. So if we were to graph this, just for some graphing practice, we would start at -4 on the y-axis, and then the 1/2 would be our slope. It's saying go up 1 over 2. So if you had to match the graph of the line, you would have to remember how to graph a line and know where to start and how to use the slope. So what they can also do is give you 2 points instead of a slope and a point. So let's say we have the point 2, -3, and the point -1, 0. So we still are eventually going to use this y minus y1 equals m times x minus x1 equation. But first we have to know how to find slope. So the equation for slope is y2 minus y1 over x2 minus x1. So we said before every point is x and y. The problem is, since we have two different, we're going to call the first point x1, y1, and the second point x2, y2. So now we have stuff we can plug into our slope equation. Slope is y2, we said y2 is 0, minus y1, -3, over x2 minus x1, so -2. And negative outside a negative really makes this plus, so 0 plus 3 is 3. -2 minus -1 minus 2 is -3. And then if we can, we divide. 3 divided by -3 is -1. So now we have to go plug it into our point-slope form. Well, we definitely know to use -1 for slope. We just solved for it. But which ones do we use for y1 and x1? Well, it actually doesn't matter. You can pick either of these 2 points, and no matter which one you use, the answer would come out the same once you solved for y. So I'm just going to cross one of them out and use the other one. We'd have y minus y1 is -3 equals -1 times x minus x1, so x minus 2. And we have to simplify this. A negative outside a negative is a plus, so y plus 3 equals, we have to distribute -1. -1 times x is -1x. -1 times -2 is +2. And we have to minus 3 from both sides, so we get the equation y equals -1x minus 1. And that would be our final answer. So a third way they can ask us about point-slope form is to give us a table full of data. So let's say we have 1, 3, 4, and 7. And 3, 5, 6, and 9. So when we have a table, that's really just a whole bunch of points. We have the point 1, 3. We have the point 3, 5. We have the point 4, 6. And we have the point 7, 9. We have a whole bunch of points. So we want to check and see, is this a line? And if it's a line, what's my equation for the line? So we're still going to keep finding slope. We're technically still doing y2 minus y1 over x2 minus x1. But we're going to kind of cheat because we want less work for us. If I had to check the slope between those 2 points, and then between those 2 points, and then between those 2 points, we'd be plugging a lot in. So the way we do this is we just take the 2 numbers stacked on top of each other and subtract them. 3 minus 1 is 2. 5 minus 3 is 2. Then we do it again. 4 minus 3 is 1. 6 minus 5 is 1. Then we do it again. 7 minus 4 is 3. 9 minus 6 is 3. So we just did all of our y2 minus y1s and all of our x2 minus x1s. We just did them all grouped together. Now we're going to find the slope by actually stacking them. Now this right side was our y values. This left side was our x values, so we'd have to go y over x. 2 over 2, which is 1. Y over x. 1 over 1, which is also 1. And 3 over 3, which is also 1. So if all of our slopes match, that means the data is linear. If our slopes match, we have linear data. If we would like to find the equation of that data, we can use the slope, which was the same for all 3, so slope, and any of the points, doesn't matter which one, so I'm going to pick one at random. Let's do 3, 5. And now we plug them into that point slope form. Y minus y1 equals m times x minus x1. We had x value and y value, so y minus 5, because our y value was 5, equals m, which was 1, times x minus our x value was 3. Now we simplify. We have to distribute the 1. 1 times x is 1x. I can just write that as x by itself. 1 times -3 is -3. Then we'd add 5 to both sides. So y would equal x plus 2. So we reviewed point slope form and finding the equation of a line if we're given data. Also, we wanted to talk about parallel lines and perpendicular lines. So lines that are parallel are two lines on a graph that would never touch. They have the same amount of tilt to them, so they would never cross each other. Perpendicular lines are lines that cross each other at exactly a 90-degree angle. So they meet at a 90-degree angle. And their slopes have special properties. The slopes of parallel lines are equal. The slopes of perpendicular lines are opposite reciprocal. So opposite reciprocal, I always think of flip and switch, because that means you flip the fraction. If I had a slope of 1/2, the slope of a line perpendicular would be that flipped upside down, 2/1, and you switch the sign, so -2/1. If we asked for parallel slope, we know slopes are equal. So if the slope was 5, a parallel slope would also be 5. So if I gave you an equation of a line, and asked you to find the slope of a line parallel, well, if lines are parallel, the slopes are the same, and we know when it's written like this, y equals mx plus b, the slope is located in front of the x. So the slope of a parallel line would be 3. If I took the same equation and asked you to find the slope of a perpendicular line, we'd still look at the 3 first. We would just know we have to flip it and switch the sign. Now to flip it, it needs to be a fraction, so for the perpendicular, I have to put this over 1. We can flip that and switch the sign, and we have the slope of a line perpendicular to our original line. So they can kind of switch it up and make it more complicated. You could write it something like this and ask you to find the slope of a line parallel. The problem is right now, I have no way to identify which number is the slope. If they asked me something like this, I would have to get y alone to figure out what the slope is. So first I'd have to minus 2x from both sides, and I didn't put it underneath the 9 on purpose. 9 and 2x are not like terms. 9 would have to have a letter x next to it in order to combine with the 2x. But since it doesn't, we just leave it as 9 minus 2x. Then we have to divide by -3. Those would be the opposite and cancel. 9 divided by -3 is -3. -2 divided by -3 would be a fraction, a decimal, 0.66666. But usually we want to leave it as a fraction, so we just worry about the signs. A negative divided by a negative is a positive. So then the last thing is, this is in the wrong order. X should come first. So if we just flip-flop them and switch the order, we'd get y equals 2/3 x minus 3. So the slope of a line perpendicular would be the same as the slope of this line, or 2/3. I keep saying the wrong word. Slope of a line parallel, not perpendicular, is the same. Slope of a line parallel is the same. Slope of a line perpendicular is opposite reciprocal. I apologize for saying the wrong word there. So if our slope is 2/3, I could also take this question one step further. I could have said find the equation of a line parallel. to the given line that goes through the point -6, comma 2. So if I changed it to say this, that doesn't mean what we've done is wrong. That's actually the first part of what we'd do. We had to go figure out slope. Now that we know what slope is and we know a point, let me double check that that's, yep, okay, same point I wrote up there. Now we can go use the point slope form of a line and plug stuff in. We have y minus y1. Again, every point is x, y, and this is our first point. So x minus 2 equals our slope, which we had to find by getting y alone, so that we could figure out what number was in front of x, times x minus x1, so x minus -6. Negative outside a negative makes a positive again, and we have to distribute 2/3. So we get 2/3 x plus 2/3 times 6. Again, you could plug that into a calculator by hitting 2 divided by 3 times 6, which would equal 4. Last step would be to get y completely alone, which means we'd have to do the opposite of minusing 2 and add 2 to both sides. So that concludes our discussion on point-slope form, writing equations from data, and slope of parallel and perpendicular lines.